Hello everyone, happy to see you here. Today we have great equation k to the power 4 equal to k minus 4 to the power 4. We need to solve this equation for k, so if you have your solution, your answer, your approach, you can also write it in the comments below and then we will check our answers. Okay, so first of all, let's write everything on the left side. Okay, let's do it. So on the right side we have k to the power 4. And this one we write on the left side but with a negative sign minus this one. K minus 4 to the power 4 equal to 0. And right now we have difference of fourth power. This is not a table case, but if we write it as difference of squares, so if we write this one as k square to the second power minus k minus 4 to the second power and once more to the second power, because basically we have 4, so then we 2 times 2 equal to 4, 2 times 2 equal to 4, so everything is great. But right now we can look at this from a different angle. If this is a and this is b, we can consider it as a difference of squares, a square minus b square. So everyone should know this formula, and this is a classic school formula, a square minus b square equal to a minus b, and times a plus b. Okay, really great. What are we going to do next? Right now, let's expand it in terms of this formula. Let's do it. So we have k square, first of all, difference, k square minus this one, k minus 4 to the second power, and the same thing, but with the positive sign. So a minus b, a plus b. So we need to change this one to the positive sign. So k square plus k minus 4 to the second power equal to 0. Right now, let's simplify it. We have squares. We don't have any fourth power anymore. So let's simplify it. First of all, on the left side, so we have k squared, the same beginning. This is a classic formula, a minus b squared. So let's expand it, but don't forget about parentheses. So k squared minus 8k and plus 16. Sorry, plus 16. And the same thing on the right side. So k squared, the same plus, and of course the same parentheses, k squared minus 8k and plus 16. Is equal to 0. Okay, right now let's open our parentheses. Let's do it. So we have k square. Right here we need to change all the signs to the opposite one. K square minus k square plus 8k and minus 16. And the second parenthesis without any changes. So because we have a positive sign before parentheses, k square plus k square minus 8k and plus 16 is equal to 0. So right now let's simplify this real quick. First of all, the main thing that we can cancel this k square on the left side, and right here we can add k square plus k square. So this is the thing that we can do quickly. So 8k minus 16, 8k minus 16 on the left side, and on the right side 2k square, so 2k square minus 8k and plus 16 equal to 0. Okay, right now we have a product of two parentheses. Just agree with me, this expression is really great for us because in the beginning we had fourth power. Right now we have a linear function, we can solve it real quick, and quadratic equation, we can also solve this real quick. First of all, let's solve this linear function, because a product of two parentheses equal to 0 when the first parenthesis equal to 0, and in our case we have a linear function 8k minus 16 equal to 0, or another parenthesis equal to 0, 2k square minus 8k and plus 16 equal to 0. So that's why we can solve this real quick. 8k equal to 16. And from here, k equal to 16 over 8 equal to 2. So k equal to 2, this is our first root. Moreover, this is real number root, and we can call it as a k first. Okay, right now let's look closely at this quadratic equation. First of all, I want to write it as in terms of like not like coefficient, I mean, yeah. We write our coefficient a equal to 2, but one really important moment, we can cancel each of this coefficient by 2. So as a result, we have like greater equation, k square, better equation, yeah, minus 4k and plus 8 equal to 0. So right now our coefficient a equal to 1, b equal to minus 4, and c equal to 8. Right now let's solve it for discriminant. So discriminant equal to b square minus 4ac equal to b square, so minus 4 square minus 4 square minus 4 times 1 and times 8 times c, yeah, equal to, so minus 4 square equal to 16, minus 4 times 8 equal to 32. So our discriminant is negative, so we have minus 16. Our discriminant is negative. So it means that in this branch we have two imaginary roots to two complex roots, because discriminant is less than the 0. So right now let's solve it. And because right here we already have k first, so that's why k second and k third will be our complex roots. Okay, so we have minus b, all known formula, minus b plus minus square root of discriminant and all over to a. So minus b minus 4 plus minus square root of minus 16 and all over to a 2 times 1 equal to. So right here minus 4 equal to 4, so we have 4 plus minus square root of minus 16. How can we write it? The best way to write it is to write it as square root of minus 1 times 16, so we can split it. Okay, and right now we can consider this expression as square root of minus 1 times square root of 16 over 2 equal to. So we have 4 plus minus square root of minus 1 equal to I, square root of 16 equal to 4 plus 4i over 2. And the final thing, we can easily cancel each of this coefficient by 2. We can expand it as 4/2 and 4i over 2. So 2 plus minus 2i. This is our k second and k third. So let's write our final answer, and in the end we're going to check real quick our k equal to 2, and I'm going to give you a few really important hints for students and for everyone. So our answer to this question, k first equal to 2, k second equal to 2 plus 2i, and k third equal to 2 minus 2i. Few really important hints. First of all, let's check real quick our k first equal to 2. So k to the power 4 equal to k minus 4 to the power 4. Let's check real quick our 2. So we have 2 to the power 4 equal to 2 minus 4 to the power 4. 2 to the power 4, of course we don't need to raise it, so we'll leave it like that. 2 to the power 4 equal to 2 minus 4 equal to minus 2. So we have minus 2 to the power 4. But because this power is an even power, so we have absolutely the same thing. We can write it as 2 to the power 4 equal to 2 to the power 4. If we raise it, we have like 16, and we have 16 right here. So our root is great. This is our real number root, and it's also a great and correct root. Right here I don't need to check it. These two roots are complex roots, so doesn't matter. Everything is great because we solved it correctly. I just want to check this real number root because we can easily check it real quick. And few really important hints, because let me do this like right here. So we have k to the power 4 equal to k minus 4 to the power 4. And few really important hints, because a lot of students might be thinking that we can cancel this fourth power. Of course you can do it, but in the same way, if you do it, so we have k to the power 4 right here to the power 4, so we cancel this 4, and we can write it as k equal to k minus 4, something like that, yeah? And then we have 0 equal to minus 4. This is extremely big mistake, but a lot of students, they do this, do the thing. And my quick tip why this is wrong, because then a lot of students might be saying, okay, 0 equal to minus 4, so something went wrong, what did I wrong? And you know why this is wrong? Because when you cancel this fourth power, don't forget about absolute value. With absolute value, this is a correct expression, okay? And then if you solve this absolute value equation, so I don't know exactly how you prefer solving this. Maybe I prefer like combine all the things like plus plus, plus minus, and a lot of these combinations, 4 combinations we will have right here, yeah? And as a result from here, you can get k equal to 2. So according to this method, I would say like this is not the full solution to this question. This is like 30% of the solution, because you solve it according to a real number root. You find only one root, but you forget about 2 complex roots. So that's why this is like a special case. So if you don't have a time, for example, in your exam, Then you can cancel this forced power. You need to put this absolute value brackets, and then from here you can easily get this k equal to 2. Okay, I really hope you understand this thing, but this is not a full solution. Full solution is this one, because we solved it according to a fundamental theorem of algebra, and it tells us that if you're talking about k to the power 4, it means 4 roots in total. In our case, we have k equal to 2, and we have 2 complex roots. According to this method, you can't solve for complex roots. Okay, this is like a special case, so if you don't have a time on your exam, so that's why you can cancel this forced power. You can put absolute value brackets, and you have only one root, and from here you can get like fewer points on your exam. But this is a full solution with the complex roots. So that's why don't be scared about this 0 equal to -1. So we have something like that right here if you cancel this forced power, but put absolute value brackets. So every time you cancel this forced power, put absolute value brackets, and then you can get at least one root. Yeah, but if you're talking about full solution, you need to spend maybe like 10 minutes to solve this question. Yeah, this is our solution, factoring, and as a result we have 3 roots, one real number root and two complex root. So I really hope you understand my solution. I really hope you understand my thoughts, because I want you to understand that right here, when you cancel this forced power, of course a lot of teachers says to students that we can do it, but in the same way just put absolute value brackets, and then you can get some points from here. But as a result, you will end up with not like a full solution. You need to solve this question like that. Of course, write your thoughts, write your response. Maybe I'm wrong, maybe a lot of teachers here, so write your thoughts, write your response in the comments below. It will be really interesting to read about it. So thank you everyone for your time. Thank you for watching this video. I really appreciate it. I want to say thank you for being here, for watching. I'm really happy that we have that type of community here, a lot of students, a lot of teachers here. So yeah, I want to say thank you for everything. See you in the next videos, and have a great day.